In this example, we see that we have tan squared and secant to the 4 that we're trying to integrate. Based on the rules that we've covered in class, we need to look for 3 different things, either even powers of secant, odd powers of tangent, or power of tangent without secant. So in this case, we have the first example, which is even power of secant. So since we have an even power of secant, we have to factor out a secant squared. So we'll do that by writing tan squared x, secant squared x, and secant squared x dx. So we're factoring out a secant squared. Now the reason to do that is so that the substitution we're going to make later has to have du equal to secant squared x dx. That's why we're removing the secant squared. In order for that to be true, then we're going to have to make this substitution. U is tan x. So this is not the step right now, but that's why we're taking that out. So hopefully we can see that. So we're told to take out an even power. If we have an even power of secant, we're told to take out a secant squared, change everything else to tan. So that becomes the integral of tan squared x times 1 plus tan squared x, because secant squared is 1 plus tan squared, times secant squared x dx. Now we can make this substitution, u equal tan x, then du is secant squared dx, du, u. So we end up with the integral u squared times 1 plus u squared du. Multiplying gives us u squared plus u to the 4 du. And then integrating gives u to the 3 over 3 plus u to the 5 over 5 plus a constant. Replacing u then gives us tan 3x over 3 plus tan 5x over 5 plus a constant.